This is a quick video trying to outline the basics behind voltaic cells or galvanic cells. Voltaic cells are spontaneous reactions and they're commonly used in things like batteries. And so this is a simplified voltaic cell. We use these for descriptive purposes, but they are not really the way they look in reality. They're always compressed to make them optimized for size and for maximum length of use and efficiency. So each battery is made with different purposes in mind, but they all are composed out of electrodes, the solid components that conduct electricity. The electrodes could be made out of carbon, platinum, or another metal. So carbon and platinum both are non-reactive, so they're inert electrodes because they are such weak reducing agents that they don't participate beyond transferring electrons. In this case, I've got a zinc half cell, and so in the zinc half cell, I get zinc ions. There are also some nitrate ions in it, and I've got a copper half cell that has the copper electrode and copper 2 ions. And I have nitrates, so I've got nitrate ions in here as well. I'm kind of drawing it small, I apologize about that, but you'll have to deal with it. Now, this is cell notation, and you'll notice that the zinc is a solid, then I have an aqueous component and a double line. The double line counts for a saltwater bridge, so it's separating the two half reactions with the saltwater bridge. This is essential to create the difference in electrode potential, or electrical potential. So you will not actually get current electricity without this saltwater barrier separating the spontaneous reactions. So I've got electrode, electrolyte, saltwater bridge, electrolyte solution, and my other electrode. Now, the strongest oxidizing agent is copper 2, because copper 2 ions are much higher on the table of half reactions. Zinc has my strongest reducing agent. So I'm going to have the two reactions are going to be copper 2 plus 2 electrons makes copper solid. This is the gain of electrons reduction. This is my strongest oxidizing agent, and that is my cathode. So the oxidizing agent is always the cathode, and then my zinc solid will become zinc ions and 2 electrons, and that is the loss of electrons oxidizing. Strongest reducing agent is my anode. So it goes SRAA. Losing electrons, oxidizing, strongest reducing agent is the anode. And so here, because the zinc electrode is where the anode occurs, this is the anode, and in voltaic cells, it's negative. Copper electrode, so in this half cell, is where we're having the half reaction where the cathode occurs. So this is the cathode, and it is positive. That is reversed in a different kind of cell, but the spontaneous voltaic cell, we have a negative anode, positive cathode, and it is always related to the gain of electrons reduction is the cathode, loss of electrons oxidation happens at the anode. Now, what's going to happen here is the copper 2 ions that are occurring here are going to become copper solid at this cathode. So the cathode is increasing the number of copper solid because the product is copper solid. Whereas at the anode here, the zinc is becoming zinc ions. So zinc ion concentration is going to increase because we're making more zinc ions. So we can, the cell will be dead when either we have used up the zinc electrode or the copper 2 ions, because those are our two reactants. Now copper 2 is a blue color, and these products are colorless. So you'll also expect that the copper 2 ion color gets less intense because it's being used up, this reactant, right? So just some practical things that are going on here. So copper 2 is using the electrons. So we need to get electrons, and electrons travel through this external circuit. And the external circuit is what it's being, the Voltaic cell is being used for. So to power whatever appliance or thing you're using, a flashlight, your phone, whatever. And the electrons are traveling towards the cathode. So electrons always travel towards the cathode from the anode. And we also have ions. So for this to work, not only do we need the two spontaneous reactions, or the two spontaneous half reactions, but we also need to have this saltwater bridge that creates a voltage difference. So what's happening in this half cell is different than this half cell. And what occurs is the anions, or the negative ions, go towards the anode, and the cations go towards the cathode. And so the saltwater bridge could have any given ionic compound dissolved in it. So if it was sodium chloride that was in this bridge, the sodium ions, or the cations, would travel to the cathode, and the chloride ions, the anode, would go towards the anode. If it was sodium sulfate, we'd have the sodium cations will go to the cathode, and the sulfate ions travel towards the anode. What that does is it allows for the electrons to go to one side without this side having much more charge than this side, or opposite charge. So it allows the equalization of the reaction for the ion charge, and because it separates the two half cells, they're able to now create the voltage. And so this is a voltaic cell or a galvanic cell, and our purpose is to get voltage, and that comes from the separation between these two half cells. You'll always be responsible in labeling a diagram for labeling your electrodes as well as your electrolyte solutions. You need a saltwater bridge. You need to say which anion is going towards the anode, what cation is going to the cathode, and the direction of the electrons in the external circuit. That's basically the fundamentals behind voltaic cells. Incidentally, we are not using up carbon solid. This could be a different, we could, because we're just making the copper solid, we could make this carbon and it wouldn't affect the actual reactions. We're still making copper solid, but we'd make it here. So that's just trying to draw your attention towards the fact that even if it is not the same chemical, so even if this was copper, or carbon instead of copper, the cell would still function. Hopefully I haven't confused you there. Most of the time, these two chemicals are the same. Copper 2 ions, copper solid, zinc ion, zinc solid. But don't be thrown off if there is carbon or platinum as one of the electrodes.